Hi, my name is Joel Matthew, UR15 CS177, and today I'm going to be creating a program on implementation of stack and queue using linked list. So, as you can see, I've created a structure named node, and I have declared integer data and a pointer of data type node. I have also created pointers top, front, rear, and temp of node data type, and I have assigned null to each of the pointers. So let's go to the main function. So as you can see, the user is asked which operations he would like to implement, whether on stack or queue. So for stack, we have the operations push, pop, and display. And for queue, we have the operations insert, delete, and display. So I have implemented each of the choices using the if else and switch case. So let's first see the stack operations. So as you can see, for push operation, we first create a new node and we assign it to the temp pointer, the address to the temp pointer, and we ask the user to enter the value for data, and the new node is assigned the value of data, and then the address of the new node is points to the top, which is the first node of the stack, and then we assign the top pointer to the temporary to the new node. So let's implement the pop function. So first we see if the stack is empty. So if top is equal to null, which means stack is empty, and we return back to the main function. So using a temporary pointer, we assign the the first node address to temp pointer, and then top pointer moves to the next node using top equal to top arrow next. So the deleted element is displayed using the temp pointer, and we then delete the pointer temp. So using display for the next function display, we first display if stack is empty, then using top equal to null. If the stack empty condition is displayed, and if not, then we first assigned top value to temp, and then until temp address is not equal to null, then we display each of the values, and the temp is then assigned the next node's position. So for queue, we have insertion operation. So first the new node is created, and the user enters the value for data, and the temporary variable is assigned the position as null. So if front equal to null, which means that the queue is empty. So front equal to front and rear are initialized to temp, and rear points to link points to null. So and if the queue is not empty, then rear is incremented. So rear points to the temp new node, and rear is assigned the address of the new node, and rear points to null. So for deletion operation, if front is equal to null, which means that the queue is empty, and we return the control back to the main function, and if not, then the temporary variable is assigned, a temporary pointer is assigned the address of the front pointer, and front moves to the next node, and the deleted element is displayed using temp, and then we delete the first element, which is temp, which is pointed to by temp. So using for display function, we first display the QMT condition using front equal to null. So and if not, then temp is assigned the value of front, and until temp points to null, we execute this while loop, and each of the queue elements is displayed, and temp moves to the next node for each iteration. So let's see how the program runs. So first let's execute the stack operations. So let's push some values. So first 12. Do you want to continue? Yes. So let's push another value, 23. So yes. And let's display the stack. So as you can see, the last element displayed is the first one which is on top of the stack. So let's implement again. Let's pop, and the last element which I entered is actually the first one to be deleted. So do you want stack operation to continue? No. So yes, I do want to continue. Let's see for q, and let's insert some values. Yes, again. So I entered 24. So let's display the q. So as you can see, the first element which I displayed entered is the first one to be displayed, followed by the next one. So let's try delete. So as you can see, the first element which I entered is the first one to be deleted. So we do not want to continue. We want to finish. No. Thank you for listening to me.